Assalamu alaikum. My name is Abdullah Ajmal and today I will be explaining lab number 6 of microcontrollers and embedded system. So basically lab number 6 is the introduction and implementation of timers and counter on Atmega 3288P and other microcontrollers using Atmos Studio and Proteus. So basically timer and counters are basically built in on an microcontroller. So if you think of this delay or consider a delay function, so what does a delay function does? It waste your machine cycles to perform a delay of particular seconds or minutes in your task. So this can also be done at parallel time by using built-in display built-in timers and timer counter module built-in timer module counter module which can be done parallel while performing other tasks in the program as well. So basically, what does the timer counter module means that it uses the internal clock of the Arduino, which is taken from the clock, and that utilizes it for the operation to count a particular overflow, and that when overflow happens, the particular task has done or the particular delay has been performed. So basically, there are four mode of operation for this timer counter module. One is normal mode, and then is compare match mode. Then we have fast PWM, correct phase correct PWM, that will be studied further in the course. We have first of all there is a normal mode in which normal counting delay is being done through the calculation of the machine cycle, and the particular value is given to the TCNT register, and particular overflow and is calculated, and when that overflow happens and the 255 values come, and then the counter is reset and the delay is performed in our task. Then the second is compare output mode, in which the particular value of the delay is directly given to the TOVO register, and when the value matches to the TOVO register, the output is 1 and the delay is completed. So basically the task that we are going to perform includes two examples and three tasks. Basically the register that we have TCCR0B, TCCR0A, TCCR1A, TCCR1B, and similarly we have three timer counter register in our particular Arduino. So basically for example one we have C program to toggle all the bits of the port B continuously with some delay using timer counter module. So basically we have written the code for calling the particular delay, and we have declared the delay TC and T0x20. We will load the value of TC and T0x20 and TC and T0, and TCCR0 because we are using in normal mode. Then TCCR0B0x01 timer, no prescaler, and while this is a compare match register that will wait for the overflow. When the overflow happens, it then resets the value. So now we will move towards the example to write a program to delay of 225.6 millisecond on pin to the port B and toggle it continuously. So we are creating a delay of 25.6 millisecond with using no prescaler 1024. The calculation are made and the value are stored according to the value with a particular delay are TCC and T0x00, TCC TCR0A 0x70. So we are using it in compare match mode, TCCR0 as 0x02 and TCCR0B for the prescaler 0x21. And then we are again checking for the overflow, and then on the basis of that overflow we are performing that particular task. So that's for the task one. We are displaying the value of TCC and T register 0, and on the and it will show the particular counting. So we have written the code. First of all, we have the LCD code, and then we have written the code for comparing both of the functions, that when the value happen it will completely update the value and keep on updating the value. Then we have in the next task we are making a digital clock using the same timer counter module. So basically what is happening, we are using the TIMSK masking registers and other registers to perform the particular task. And for the final task, what we are doing, we are making counting an external delay. For example, we have a switch and it is turning on and off, and we are counting that event over our LCD on the presses of that button. So now let us move towards the Proteus simulation. This is the Proteus simulation for our first example. So we will so this is the first example in which We are calculating the particular delay. Dealing with a particular till the LCD is not turning on and off. So now we will move further towards our second example. In the second example, what we are doing, we are creating a delay of approximately 26.5 milliseconds onto our LCD, onto our LED that is connected to the pin number 2. So it is creating a delay of 26.5 milliseconds accordingly. So now we will move towards the to our task number 1. So basically what in task number 2 1 we are making it as our simple counter. So it is a simple counter that counts the value of the overflow of our TCNT register. So it is counting on the basis of that. So now let us move on towards our next example. Oh, sorry, next task. So in the next task, we have again created a clock using digital clock. So now I will display. So this is a digital clock using timer counter module. So it is counting from 0 to 59, and then the time value is up to 10. When time reaches 59, then the next value is calculated. So now we will move towards our counting that external event. So now we can count the external event. So it will count 1, 2, 3, 4, 5. We can count external event based on this. So now let us move towards the hardware implementation. So these are the hardware implementation. So these was the task for the last, in which we performed external event counting. So this is task number 2, in which we have formed a clock using the timer counter module. Then this is the next video for again for the counting, and this is the video for the minute clock. So that's all from my side. Thank you for watching.